In this video, we're going to look at the equation of a tangent line. So first, in our do now, we want to solve the system of equations below. So we're given y equals x plus 2, and we also have x squared plus y squared minus 6x plus 2y equal to 26. So we can graph y equals x plus 2, no problem. We know the y-intercept is 2, and the slope is going up 1 over 1. So I'm plotting some of these points on my graph here. And we're going to draw a line extending through like this. So that's y equals x plus 2. Now, unfortunately, we can't graph the circle like this because we have to figure out what the equation is first. So I would recommend that we rewrite this. We get x squared minus 6x plus some number plus y squared plus 2y plus some number equal to 26. And we have plus 2 boxes here because we added 2 things on the left, so we're going to do whatever the same thing is to the right. So first, we take that middle number, negative 6. When I divide it by 2, I'll get negative 3. And when I square that, I end up with 9. So I'm going to have 9 in both boxes, one on each side of the equation. We're going to do the same thing with the y's, but so 2 divided by 2 is 1. And when I square that, we get 1 on both sides. So focusing back on the x squareds of the equation, that's going to factor to x minus 3, x minus 3. We're looking for a number that multiplies to 9 and adds up to negative 6. That's why we have the minus signs. So we have x subtract 3 squared. And then over with the y's, we're looking at y plus 1 times y plus 1 to get us y plus 1 squared. And we're going to add that up. On the right side, we're going to get equal to 36. This means our center of our circle is 3, negative 1, because our signs switch, knowing our formula from the last lesson. And the radius is 6, because the square root of 36 here. So now I'm able to graph this by starting at 3, negative 1. And I'm going to count 6 in each direction. And I'm going to do my best to make a nice circular picture around this. Bear with me, don't judge too hard. But what type of line is y equals x plus 2 compared to the circle? Well, notice it does have 2 intersections. So any line that touches a circle in 2 places is a secant. And what is the maximum number of solutions a line in a circle could have? 2. Because we're looking, those intersections would be the solution set. Just like when you find the solution of 2 lines, it has 1 point, this is the maximum number because our line can't loop around and intersect our circle anymore. What we're going to focus on a little bit more today, though, is if we have line M that's tangent to A at point B, what is special about the relationship of line M and segment AB? We've dealt with this earlier in the year. We should know that a radius, AB, and a tangent always makes 90-degree angles. So we know that AB is perpendicular to line M. Okay, so we can say radius tangent there. That being said, we're going to look more about the equation of a tangent line today. So if we were dealing with a segment AB whose endpoints were given, we're going to find the slope. We've done that plenty of times in the past. So we take the change in y over the change in x. So I'm looking at 6 subtract a negative 3 over 3 subtract a negative 3. And when we look at something like that, we're looking at positive 9 over positive 6, and it simplifies to 3 over 2. And if we wanted the perpendicular slope, we know that that's just the negative reciprocal, so we're going to have negative 2/3. So now we can write the equation of the line that passes through point B and is perpendicular to AB. So this part is important. Pass through point B means point B has to be the point we can't use point A. It's perpendicular to AB, so we know we're using this slope. So we can find it in point slope form if we want. Y minus y1 in this case would be 6 from the point equals the slope m, negative 2/3. And with x minus 3. But we want to be careful in that sense because we did want to find y-intercept. So to do that, we can distribute through. We'll get y minus 6 equals negative 2/3 x. Negative 2/3 times 3 is going to be positive 6. We're going to add 6 to both sides. Get y equals negative 2/3 x plus 12, which means the y-intercept in this case is 12. And you would have used slope-intercept form. Y equals m plus b would work the same way. So in circle A, it is shown that the center of the origin and a radius of 5 is the circle. Point B lies on the circle as the coordinate 4, 3, and it's tangent to that point. So it means it touches once in that specific location. So because it's tangent, remember we talked about before, we first are going to write the equation of the circle below and show that 4, 3 must lie in it. So we know the center is the origin. So I can write that as x squared plus y squared equals, now I'm just going to count my boxes here. 1, 2, 3, 4, 5. So 5 squared will get us 25. To show that that point is on there, we're just going to plug in this point. 4, 3 is x, y. So 4 squared. Where's getting that cube from? Plus 3 squared equals 25. 16 plus 9. When we add that together, it does equal 25. So we know that that point does check out, and it is on our graph of this circle. So first thing we can do is find the slope of AB. So remember, we can count however many up and however many over. I'm counting up 3 over 4. We want to write the equation of line M. What we should remember, this part's important, is that the radius and tangent always are perpendicular to each other. So the slope of line M is going to be perpendicular to the slope we just found, negative 4/3. And we know the specific point that they both share is 4, 3. So we can use that in point slope form. So I'm just going to plug now. Y minus 3 equals negative 4/3 of x minus 4. So bear with me with this pen. I want to finish off strong here. Okay, good. Okay, so really when we're writing the equation of a tangent line, we need to make sure that it's perpendicular to our radius and it's going to be that point that they both share. So now when we consider the circle whose equation is x minus 6 squared plus y plus 3 squared equal to 80 and the point 25. Show that A must lie as point. Why don't you take a moment and try that part on your own? So you'll see when we plugged in 2 for the x value, 5 for the y value, we should have gotten 8 equal to 80. So we know that the point does lie on a circle. Now we want to find the slope of the line segment that connects the center of a circle to this point. So let's use our graph since it's here. Our center we know is 6, negative 3. 6, negative 3 is right here. If this is an origin where I meet. Now, let's find 2, 5. We want to find the slope connecting those two pieces here. So, finding a slope, we know no big deal. We're just going to count down and over. So when I count down, I'm counting 1, 2, 3, 4, 5, 6, 7, 8, and over 4. So right now, the slope that connects these two is negative 8 over 4, which simplifies to negative 2 over 1, or you can just leave it as negative 2. And we want to write the equation law of tangent line. So just roughly, I'm not going to draw this perfect to scale, but since this is my center down here, we know that we'd have a circle that would come somewhat around like this. It doesn't have to be perfect, but my tangent line, if I think about this, the line we just found here, this is my radius, because it's from the center of a circle to the edge of a circle. So my tangent line needs to make sure that it is perpendicular to that slope. So our perpendicular slope would be positive 1 over 2. I'm going to count that from this point. I can count up 1 over 2. 1 over 2, 1 over 2. I can do the same in the reverse. Because we want a line that's only going to touch our circle once. And, oops, I missed. So we can get equation of the line just from using our picture alone. Or we could plug it in the point formula again. Because we know that our slope is here. We know it hits the point 2, 5. So either way, we could write in point slope form. Let's say it was y minus 5 equals 1/2 x minus 2. And we could distribute if we wanted it in slope-intercept form. Or here, if we look at our graph, we know we have y equals 1/2. We know what the slope is already. And you can see the y-intercept is at 4. And that's the same thing we would have gotten if we distributed that through from the point slope formula. Okay. Now, exercise 5. We have a circle whose equation is given. We want to write the equation of line and tangent to the circle at a point of 212. So we're going to think about that. Try to do this one. Find the slope, find the perpendicular part, and then come back. Hopefully you recognize the center point was negative 4, 2. And the point that's on the circle, that's the point of tangent, is 212. So first we found the slope to be 5/3. A radius and a tangent are always perpendicular, negative 3/5. And then the point 212 is the one we want to